ये बात है। Class start M.Sc. బుజ్జిగాడేనా ఓచిలే ఓచిలే చూడు స్టార్ట్ అయిపోయింది చూడు చాలు బాగాలేదు
గ్యాస్ అయిపోయింది చిట్టమ్మా ఆడియాము ఇప్పుడు సంవత్సరం లాస్ట్ డెలివరీ కంట్రోల్ పడుతుంది. వాడు బస్తలు పడతాడంటే కానుకలు కంకులు అని చెప్పి యాక్చువల్ మళ్ళా పట్టుకుని ఇక్కడే. అందుకే ఇప్పుడు యూనిఫామ్ అవి పెట్టి అట్లా చేస్తున్నాను.
పట్టకుండా కదా మనం చిన్నపోయినప్పుడు మనకు గైడ్కి వచ్చిండు. ఆయన ఉద్యోగం ఉండేది మన లబ్ధంతే. ఆ పోరి చర్చిలో పోయి కానుకలు తీసుకొని చెప్పాను. చెప్పి అన్ని ఏ అన్నని నన్ను చూడంగానే ఇట్లా
ఇంట్లో అందరికీ తెలియాలా?
అట్లా చేసుకున్నాం మేము బయట అరే పోరి అట్లా చేసి
Good evening, all. Am I audible to you? Hello. Can I get one reply from anyone?
Yes, sir.
Yes,
Yeah,
sir.
am I audible?
Yes, sir.
You are audible, sir.
Yeah. Okay. Yeah, welcome to the class. This is Kodishwar Rao, Department of Chemistry, Dr. B.R. Ambedkar Open University. Right. Have successfully completed first class. Have you completed first class?
Completed, sir.
Yes, sir.
Yeah. Okay. The class duration is only 1.5 hours. Okay. In the previous class, sir asked you what is the time duration of the class. You tell that 2 hours. Due to that reason, it is delayed. The second class is delayed. Okay. Even after that, I am giving some time to refresh and get some fresh air. Due to that reason, I am starting late for 5 minutes after the class of first. Right? Yeah. How many of you joined from Warangal, Vizag, and Tirupati? Is there anyone there? From Warangal, from Tirupati, from Vizag? Just
Sir,
message
myself from Vizag, sir.
from Vizag.
Yes,
Right,
sir.
right. Their offline classes, are you attended offline classes there?
Yes, sir. Almost 2 classes I have attended, sir.
Only 2 classes you are attended.
Yes, sir.
Okay, I think as per the schedules, in some courses, the first 2 blocks are completed. In some courses, middle 2 blocks are completed. Okay, here in the Hyderabad, we have to discuss 2 blocks, but during the sessions, we are able to complete only 1 block. As per the schedule, we are going to discuss about the block 3 and block 4 in online sessions. If any time is remain, again we are repeated the first and second blocks in this during the session. Okay, even though if the classes are not sufficient, as my personal interest, I will take 2 to 3 extra classes also for covering all the syllabus. You don't worry, don't bother about that. Now,
Thank you, sir.
Today I am going to start have you received all of you course material? All of you. Receiving means you need to collect the books for first year. How
Yes,
many
sir.
of you have collected or how many have received from through post? I hope all the people are received.
Yes, sir.
99% most of them are received from the university through post.
Yes, sir.
Yeah. Okay. Then okay, I'm going to start the paper 2, organic chemistry. In that the block 3 is aromaticity. My screen is visible to you all?
Yes, sir.
Yes, sir. It is visible, sir.
Visible to you all.
Yes, sir. Yes, sir. No
Right.
issue.
The block 3 is aromaticity. In that aromaticity, we are going to discuss some subtopics, benzenoids, non-benzenoids, sorry. And properties of the some aromatic compounds and in the sense of reactivity. Properties of some aromatic compound. Yeah. Just a minute, I will minimize these videos. I will keep aside. It will be somewhat disturbing to me in the screen. In that the first unit, we are going to start. Unit 11 it is, I think. Yeah, unit 11. Concept of aromaticity. In that, in this concept of aromaticity unit, we are going to discuss about the definition of aromaticity and what is the properties of aromatic compounds, how, what way it is different from the aliphatic and simple compounds, cycloalkanes, acyclic compounds, and corresponding conjugated open chain systems, how it is different from those compounds, right? Next, what is the criteria for aromaticity? What is the criteria for aromaticity and the characteristic features of aromaticity? After that, we're going to discuss about the benzenoid and non-benzenoid ring systems and what is the aromatic property in larger member rings and heterocyclic systems, right? Polynuclear aromatic systems, we are also called as polynuclear hydrocarbons. These are, and we are going to discuss about the Huckel rule. In that Huckel rule, what are the postulates of Huckel rule, and what are the limitations of Huckel rule, and what is the alternate and non-alternate aromatic compounds, or alternate and non-alternate hydrocarbons, and Craigstone. These are the topics we are going to discuss during this session. Right. Now, first coming to the aromatic compound. Generally, this is a trivial name, a old name. Right. In that nomenclature, as per that nomenclature, aroma means, in most of the TV shows, in several books, in dailies, we are reading that aroma. Aroma is a good odor, good or pleasant odor. That means the compounds which are showing a good odor are known as aromatic compounds. Initially, in the trivial nomenclature, as per the trivial nomenclature, they don't know the properties of the compounds, but simply based on the order, they are proposing that those compounds are aromatic. Those compounds are aromatic. As per the blind knowledge, they are considering the blind knowledge. They simply classify the molecules which are having the good and pleasant order. Those are classified as aromatic compounds or aroma compounds. Later it is converting into aromatic compounds. Now, nowadays, that means after evaluation of several advanced theories, as per the advanced theories, aromatic compounds are classified as planar. What is planar? What is monocyclic? I will tell you after the definition. Planar, monocyclic, or polycyclic. It may be monocyclic or polycyclic. Polycyclic, conjugated polyenes. Conjugated polyenes, which contains which contains 4n plus 2 pi electrons, where n is equal to 0, 1, 2, 3, and so on, which are delocalized in the conjugated framework. Conjugated framework are known as aromatic compound. First definition, you understand that. Later we move into the next. Right? Planar, monocyclic, or polycyclic conjugated polyene, which contain 4n plus 2 pi electron, where n is equal to 0, 1, 2, 3 simple integers, which are delocalized in the conjugated framework. Conjugated framework. Right? Are known as aromatic compound. Then, as per the definition, the compound should be planar. First of all, I am going to show you what is the planar. There is a double bond. This is a C double bond C. There is a carbon, C double bond C. Now this carbon is sp2 and this is also sp2 hybrid. In the sp2 carbon, here, all the attached bonds, these two terminal bonds and this pi bond and sigma bond, are exist in the same plane. It is also similar to the next terminal carbon. Now the total olefin is exist on the same plane. Therefore, this molecule is known as planar molecule. This molecule is known as planar molecule. So, for example, you consider a simple tetrahedron molecule, sp3 carbon molecule. Look at here. This is the tetrahedron shape. It is a three-dimensional structure, right? If you consider any two bonds and carbon within the plane, the remaining bonds, one is the below the plane and one is above the plane. Now this is not a planar structure. This is not a planar structure, right? Similarly, if you consider this is the sp3 hybridization. When you coming to hybridization, it is a linear structure, one-dimensional structure. It is a two-dimensional geometry. It is having two-dimensional geometry.
Bye.
It is showing a two-dimensional structure. It is showing three-dimensional structure. It is one-dimensional. It is a linear. It is showing SP hybridization. Now, as per the definition, it should be planar. It should be planar and monocyclic or polycyclic. You know that cyclic system. This is the cyclic system. Suppose everybody knows the benzene is the primary structure for the aromaticity. And polycyclic system, for example, more than one cyclic system or more than two cyclic. Anthracene, right? This is the monocyclic system. It is the polycyclic system. Polycyclic system. Now, in this two structure, you consider that every corner of the edge of is known as a carbon. This carbon is a sp2 hybrid carbon. That means all 6 carbons, in the 6 carbons are there, all are sp2 hybrid. Right? Due to the sp2 hybridization, all carbons attached bonds are within the plane. Therefore, the entire structure is placed on a single plane. Single plane. Right? Similarly, if you take anthracene, this will also having the same structure. Planar. Both are planar, monocyclic or polycyclic. Next, conjugated polyenes. You know that double bonds are 3 types. Suppose if in a molecule more than 1 double bonds are there, that is called as polyene systems, right? Now the 2 double bonds are adjacent together, known as cumulative double bond. Cumulative double bond, right? If 2 bonds are separated by one single bond, it is known as
Isolated double bond.
yes, conjugated double bond, right? If these are isolated by more than one single bond, what are that? Isolated double bond. Now look at here. Our requirement is what here? Conjugated polyenes. Conjugated polyenes. Look at here. These are the conjugated systems. This is that means the 2 double bonds. Suppose within the system 2 double bonds are there. The 2 double bonds are separated by a single bond. Now that is known as conjugated system. It is the cumulative system. It is the isolated. Now coming to here again, benzene and anthracene. This is the double bond and single bond and double bond, single bond, double bond and single bond. Now that in this structure, alternatively double bond and alternatively single bond. Right? Now this is known as conjugated polyene. More than 2 double bonds are there in a molecule, that is called as polyene system. That polyene is a conjugated polyene. Here also, in the anthracene system also, all the double bonds are alternatively arranged. These alternatively arranged double bonds are conjugated polyene. As per the definition, conjugated planar, monocyclic or polycyclic, conjugated polyene. which contain 4n plus 2 electrons. Here the again rule, Huckel rule, it is 4n plus 5 electrons. Suppose if we consider n is equal to 0. Now, what is that? 4 into 0 plus 2, 5 electrons. It is having 2, 5 electrons only. For that example, this is the cyclobutene carbocation. Sorry, cyclopropene carbocation. Right? If we consider here the n is equal to 1, where n is equal to 1. 4 into 1 plus 2, 5 electrons. What is that? 4 plus 2, 5 electrons. Then 6, 5 electrons. How many electrons is there in this benzene? How many electrons?
5 electrons.
Right. This is having 6, 5 electrons. Right. In this, how many electrons? 6 plus 4 plus 4. 14 5 electrons. 14 electrons. How it is possible? Look at it here. Where n is equal to, just a minute. Where n is equal to 2. 4 into 2 plus 2, 5 electrons. 8 plus 2, 5 electrons, that is 10, 5 electrons. Right, n is equal to 3. 4 into 3 plus 2, 5 electrons. That is 12 plus 2, 5 electrons. That is 14, 5 electrons. These two are satisfying Huckel rule. It is also satisfying, benzene is satisfying Huckel rule, and anthracene is also satisfying Huckel rule. Now, another term is used, delocalization. Delocalization. The word is used here, delocalization. Yeah, delocalization. Delocalization. These are the basic things first you need to understand. Then only we can understand the remaining concept. That's why I'm going slowly here. Right. Now you look at here, conjugated acyclic polyene system. Right. Now, each carbon is a sp2 carbon. That means each carbon is having one hybridized p orbital. Now, each one is having one electron. Each one is having one electron. Is 1, 2, 3, 4, 5, and 6. 6 carbons are having 6 electrons. Now, these 6 electrons are equally shared by the 6 carbon atoms. This is known as delocalization. That means this particular electron will not belong to any particular carbon, but all the 6 electrons are mutually shared by the carbon. Now, it is responsible for the formation of an electron cloud below and above this conjugated pi system. Suppose if we treat it as a electronic cloud, from this electronic cloud, the required electron density is acquired by the carbon. Now, this is known as delocalization. Delocalization. Right. Here, the delocalization is in the form of linear. It's like a straight line. But when you coming to the benzene, look at here. The conjugated system is a cyclic conjugated system. Cyclic conjugated system. When you consider Every carbon is also having unhybridized p orbital. Now all the electrons present on each carbon, one electron, second electron, third electron, fourth electron, fifth electron, and sixth electron. All these electrons mutually shared by equal manner. Now this is also delocalization. This delocalization is circular manner, a circular array of delocalization. This is circular error. There is no disconnection. But when you compare to the acyclic system, there is a disconnection. This is the end point. This is the end point for the delocalization, right? There is a boundaries are there, but in this case there is no boundaries. Now this is an effective and closed delocalization. Due to that reason, it is gaining more thermodynamic stability when we compare to the acyclic system. That is the reason aromatic compounds are more thermodynamic stable when we compare to the corresponding polycyclic acyclic conjugated systems. Acyclic conjugated polyene system, right? When we compare to the same 6 number of carbons are there here, 6 number of carbons are there. In this also 6 number of carbons are there. But when we comparing, here also delocalization is there, here also delocalization is there. But when we comparing these two, the cyclic system is more stable than this acyclic system, right? Now all the conditions you understand now, right? A planar, monocyclic, or a polycyclic conjugated polyene which contain 4n plus 25 electron, where n is equal to 0, 1, 2, 3, which are delocalized in the conjugated framework, are known as aromatic compound. I hope this one is clear. Is my voice is audible to you? Someone is sending a message, voice is not audible. Voice వినిపించటం లేదు sir. Please respond, anyone, please. I think it is the
Okay, sir.
sleeping time and drowsy time. Please be careful, carefully listen. Am I audible to you or not?
Yes,
You are
sir.
audible, sir.
Yeah. Some people may not be, so maybe arising this problem due to the your network problem, maybe. I think. Right? Next. This is the definition of aromatic system. Then what are the properties, unique properties of aromatic systems? Now, the characteristic features of aromatic compounds. The first one, this word is already mentioned, that is greater thermodynamic stability. Greater thermodynamic stability. Yeah. Every compound is having some thermodynamic energy. The system which is having lesser thermodynamic energy, that is more stable. By which it will be stabilized. The same explanation, whatever I have given here, this one. This is the acyclic system. This is the cyclic system. The delocalization of 5 electrons in the acyclic system is incomplete. Delocalization of 5 electrons are incomplete, right? But in the case of cyclic system, it is a circular array manner. It is a complete and a perfect delocalization system. The delocalization is more perfect then the system energy will be decreased, by which the thermodynamic energy will be decreased. Then it will be getting higher thermodynamic stability. Higher thermodynamic stability. Now, by which we can say that aromatic compounds are more thermodynamically stable than the corresponding acyclic conjugated polyenes. I think most of all you know what is the acyclic conjugated polyene. What is cyclic conjugated polyene? Is it necessary to again I am repeating? May I repeat it again? I think most of all you known. It is already in the degree level we discussed. In the degree level chemistry, it is already discussed. Conjugated polyenes. This is the conjugated acyclic polyene system, right? A cyclic system. It is the cyclic system. Correct? Is it correct? Yeah. Next, coming to chemical reactivity, aromatic compounds and their corresponding acyclic systems. Next, second one is characteristic features, chemical reactivity. In this chemical reactivity, look at here. Suppose if we consider a simple olefin, it is olefin or alkene, you can yes, alkene. Now, suppose it is on hydrogenation, that is addition of hydrogenation in presence of nickel, that leads to the formation of a saturated addition product. Addition of hydrogens, or take simple bromination in the non-polar or polar solvent. If you take the chloroform solvent or an acetic acid or an acetic acid, then it leads to the formation of dibromo product. 1,2-dibromo product. Right. These are the addition reactions. These are known as addition reaction. Or you can also add simple HBr, hydrobromination reaction, CH3, CH2, Br. All these are addition reactions, by which you can understand that the olefin systems are undergoing addition reactions. Those addition reactions are characteristic reactions for the olefins. Those are the characteristic reactions for the olefins, right? Now, coming to the aromatic compound. For example, you take aromatic compound, the same bromine added in presence of acetic acid, What is the product? Instead of addition, it takes place bromobenzene is product. Bromobenzene is the product. Now this is known as substitution reaction, especially it is the electrophilic substitution reaction. Electrophilic substitution reaction. Right. Now, simple observation. Aromatic compounds are showing substitution reaction. Aromatic compounds are showing substitution reaction. When we come into the differences in the olefins and aromatic compounds, olefins are undergoing addition reactions. Aromatic compounds are undergoing substitution reaction. That is the difference from the, even the both are unsaturated compounds, but olefins are showing addition reactions, aromatic compounds are showing substitution reaction. Next, another important phenomenon, spectroscopic phenomena. Especially we consider H1 and MR. In the H1 and MR, there is a scale, that is we are indicating a delta, that is called as chemical shift. Chemical shift. Yes, who is in Jayalakshmi? You are raising hands. Is there any question? Jayalakshmi garu, you are raised your hand. Is there any question? Is there any doubt? Right, okay. Now this is the chemical shift, delta. Generally, the scale is indicated from the 0, delta, 2, and above. Generally, we see in that maximum, the most of the compounds, that is 10 delta, and the more compounds are positively charged carbon compounds now show above 10 also, but this is the general scale 0 to 10 delta. This is called as downfield. This is called as upfield. Right. That means the peak appear may be in the upfield, the precessional frequency or chemical shift is low and or minimum. If the peak is appear at downfield shift, the precessional frequency or chemical shift is more. Then, when we coming to the aromatic compounds or aliphatic compounds, aromatic in the proton and MR spectra, just we consider the benzene. Each carbon is having one carbon is attached with one carbon, sorry, one hydrogen. That is 6 hydrogens are there. C6H6. Now, all these are aromatic hydrogens. These all hydrogens are appear at 7.2 delta. 7.2 delta. That is the more chemical shift value. These are the aromatic protons, aromatic signals. Now, when you're coming to a olefinic double bond, there is attachment of, suppose, the 4 hydrogens which are attached. These 4 hydrogens are called as, these are the aromatic protons or hydrogens. These are the alkene or olefinic protons. These alkene or aromatic protons are showing the delta value. There is a range value in between, that is 6.0. You can call it 5.0 to 6.0. Sometimes it may also decreases whenever it is attached to an electron withdrawing group, like that. Electron donating group is there, then automatically it will be shifted to upfield. Okay, this is the scale is shown by the olefins. These are the aromatic protons at 7.2. These are the signal range shown by the olefinic proton. Now this is known as the characteristic features of aromatic compounds. Aromatic compounds are undergoing, first of all, when you come into thermal stability, aromatic compounds are having higher thermal stability when you compare to olefins. And when you come into the reactivity, aromatic compounds are undergoing substitution reaction rather than addition reaction, even though it is having the unsaturation. And coming to the spectroscopy, a particular spectroscopy, H1 and MR spectroscopy, clearly indicates that aromatic protons at upfield, downfield region, and olefinic protons shown at upfield region. Aromatic protons at downfield region, olefinic protons at upfield region. Okay, these are the characteristic features. Okay, these are the aromatic compounds. Whenever they are satisfying these conditions, those are known as aromatic compounds. Now, next, compounds in the aromatic concept, we are also frequently heard one word, that is anulines. Anulene. What are anulines? These are monoplanar, first planar, monocyclic, conjugated polyenes, conjugated polyenes, with CN, molecular formula. Are known as anulines. For example, benzene, C6H6. It is known as 6-anulene. 6 is in the square brackets. Anulene. Right. This is known as 6-anulene. In a similar way. C4H4.
4 anulene.
Anulene. C4H4. 4-anulene. Right. Then coming to cyclooctatetraene. Cyclooctatetraene. This is the 8-membered cyclic system. Right. This is C8H8. Is known as 8-anulene. We have several numbers of anulines are there. Again, in the anulines, aromatic anulines are there. Aromatic anulines, what you called as anti-aromatic aniline. Anti-aromatic aniline. Right. What are aromatic anilines? What are anti-aromatic anilines? Which are having N plus 2,5 electrons are known as, that means that aniline system which is existing with 4 and 5 electrons are aromatic anilines. Next one, anti-aromatic anilines. These are only having 4 and 5 electrons. When you coming to here, the benzene is 6 aniline, it is having 4 and 5 electrons. Right. Therefore, it is aromatic aniline. It is aromatic aniline. When we coming to 4 aniline, it is having only 4 and 5 electrons. How many electrons? Only 4 electrons are there. Electrons are there. Therefore, it is known as anti-aromatic aniline. Right. Now, why we are classifying into aromatic aniline, anti-aromatic aniline? It is also again based on the stability. It is comparing with acyclic system. Right. Here I am going to give a small chart. It is already given in book, your book also. Right. It is the
హలో సార్
yeah.
సార్ ఈ అనిలిన్ అనేది ప్లేనర్ అని చెప్పారు కదా సార్
Can
Sir,
you
okay.
can you speak it loudly, please?
సార్ ఇది అనిలిన్స్ అనేవి ప్లేనర్ అని చెప్పారు కదా అనిలిన్ సో మీరు సిఓటి సైక్లో ఆక్టా టెట్రాయిన్ అనేది నాన్ ప్లేనర్ కదా సార్ అది ఎగ్జాంపుల్ దీనిలో చెప్పకూడదు అనుకుంటా
Yeah, actually it is the hypothetical exam. It is the tub shaped non-planar. Non-planar. It is the tub shaped. But when we coming to in hypothetical manner, it is considered as a planar. It is having aniline electronic configuration. CnHn is satisfied. Then it is taken as example for 8 aniline. Right?
Yes.
8 aniline. But when practically it is aniline.
Sir.
Practically it is not aniline.
Sir.
And moreover, most of the anti-aromatic compounds are non-planar.
Sir.
Non-planar, because up to 4-5 electrons containing 1,3-butadiene is a simple planar, but it is not satisfying the Hooke's rule. It is anti-aromatic. But above 8 aniline and above, these are non-planar and not satisfying the basic definition as well as the Hooke's rule. That is the reason they are anti-aromatic. That is also one factor that is showing anti-aromatics. Right? Now coming to here, the next, we are using the terminology aromatic and anti-aromatic. Now this is the energy level, simply called as energy of acyclic conjugated polyene. This is the energy, rising of energy. This is indicating the energy. Right? This acyclic conjugated polyene system's energy is like that. In between this line, suppose. Right? if the system cyclic conjugated polyene system lower than the, that is the thermal energy is lower than the conjugated acyclic system, or we can also call it as positive resonance energy, that is known as positive resonance energy, or thermodynamic energy of the system use the word lower thermodynamic energy of the system than the this conjugated acyclic conjugated polyene system, or another one, more thermal stability, thermal stability. Now, and they called it as these compounds are aromatic, right? Why it is aromatic? When we compare the energy of the that is the thermodynamic energy of acyclic conjugated polyene with the other compounds which are monocyclic or polycyclic conjugated polyenes with the delocalization of pi electrons having the lower thermodynamic energy and having the more thermodynamic stability are known as aromatic compound. Aromatic compound. And the next one, the compounds which are having negative resonance energy. Negative resonance energy higher thermal energy, thermodynamic energy, lower thermodynamic stability. These are known as anti-aromatic. And some other kinds of compounds are there. Generally, larger anilines, that is greater than 26 carbons, or any other conjugated polyene system, monocyclic or polycyclic conjugated polyene system, which are having the same energy as the energy of acyclic conjugated polyenes are known as non-aromatic compounds. We simply understand that non-aromatic compounds is those are not aromatic. The first thing, there is no a discussion about the aromaticity of that compound. That is non-aromatic compound, right? Even though those are satisfying the Hückel rule or not satisfying the Hückel rule, whenever the aniline is having greater than 26 carbons, those are considered as non-aromatic compounds, right? And other factors, some compounds they may not be anilines, but having the monocyclic system or polycyclic system, conjugated polyene systems, they may satisfy the Hückel rule or may not satisfy the Hückel rule, are having the same energy with the energy of acyclic conjugated polyenes are known as non-aromatic compound. When you consider it, and the stability and the stability criteria. Aromatic compounds are more stable than the non-aromatic, and non-aromatic are more stable than the anti-aromatic.
Anti-aromatic.
Okay, this is the thing we can understand from this. Next, when you come into energy, thermodynamics. If you not understand my writing, please ask me again, because this is the writing pad. It will slips by the that plastic pen, right? If you have any doubt during writing, right, in my writing, if you can feel free to ask. Okay, right. Here the anti-aromatics are more energy. Anti-aromatic systems are having the more energy than the non-aromatic,
Then aromatic.
and simply you can say that reverse of the above sequence. Right. Now, here we are using resonance energy. What is the term? We are using a term resonance energy. Now, this resonance energy also called as delocalization energy. Resonance energy or delocalization energy. Delocalization energy. Yes. For example, cyclohexene. This is the cyclohexene. Cyclohexene. Now, I am conducting hydrogenation reaction. Hydrogenation reaction means addition of hydrogen. Hydrogenation, not hydration. Hydration means addition of water. Hydrogenation is addition of hydrogen. Right? Now, I am applying hydrogen pressure in presence of Rankine. You can use. Then it undergoes reduction. Then it leads to the formation of simple cyclohexane. This is the cyclohexene. This is cyclohexane, cycloalkane. Right. For this, in this conversion, the heat energy is evolved. The heat energy is evolved. That means it is a stable system when we compare to the simple. It is a stable system when we compare to this. Now, it evolves 120 kilojoules per mole. Kilojoules per mole. Right. Now, we know that the benzene is a cyclohexatriene. Hypothetically, we treat it as it is a cyclohexatriene. It is having 3 double bonds. It is having 3 double bonds and including added 3 moles of hydrogen. At the same time, increasing the concentration of nickel. Then also it leads to the formation of cyclohexane. Hypothetically, this reaction evolves how much energy? 360 kilojoules per mole. That is 122, 3 double bonds. That leads to the generation of 360 kilojoules per mole. But this is the theoretical value. Theoretical value. But the actual energy is released by, if you take the benzene, I'm just a resonance is I'm going to take. This is the Kekulé structure, or we can consider another Kekulé structure. This is Kekulé models. Okay, this is not the exact structure of benzene. This is the Kekulé's models. Resonance, we call it as resonance structures. This is known as resonance hybrid. Just a minute. Right. This is the resonance hybrid. What is the resonance hybrid? What is the difference between resonance structures and resonance hybrid? The difference between the resonance structure and resonance hybrid is the energy of the resonance hybrid is averaged or less than the energy of resonance structure. That is the more stable form of that compound is the resonance hybrid, not the resonance structure. Right? Now, which is on hydrogenation in presence of iron and nickel. That is also producing same cyclohexane, but it evolves 208 kilojoules per mole of energy. Kilojoules of energy. Then what is the difference? This is the practical energy. Practical. The energy evolved theoretically 360 kilojoules per mole minus practically evolved 208 kilojoules per mole. Then what is the difference? 152 kilojoules. Now this energy is known as resonance energy. Resonance energy or delocalization of energy. What is delocalization of energy here? Resonance energy is nothing but a delocalization energy, but this delocalization energy is due to the delocalization of pi electrons is responsible for the decreasing the energy of the system, decreasing the energy of system. Then that energy, this energy is the decreased energy. Only 208 kilojoules is evolved. Then this difference energy is known as delocalized energy. Delocalized energy, right? Then when you're coming to yes, next coming to Huckel rule. Yes. Is very important. Based on this rule only we can predict the aromatic property. Huckel rule. What is Huckel rule? The delocalization energy you can also calculate by the heat of combustions, heat of hydrogens, okay, lattice energy difference. Several calculations are there. You can take any calculation, you can calculate. The benzene shows the lower energy than the cyclohexatriene. Okay, but the only difference is we have a model for benzene, but that kind of model is not available for the several aromatic compounds. Okay, we cannot predict the delocalization or resonance energy for so many compounds because of there is no model compound is available, right? Okay, can I stop today? Tomorrow I will start. I will continue. It's already 9:40. It is very late
Yes,
night.
sir.
Okay, I don't want to
Okay.
bother you. This is the first day.
Yes, sir.
Yeah, tell me.
Thank you, sir.
Okay, thank you. Good night.